These are the examples for Algebra 2B, Credit 1, Lesson 13.2. Lesson 13.2, we're going to be talking about exponential decay. In our last lesson, we talked about exponential growth. This is a similar concept, except instead of the item that we're talking about increasing in value or amount, it's going to be decreasing. And so the formula is similar. Remember in the last lesson was y equals a times 1 plus r. The only difference here is it's 1 minus r to the power of x. So let's take a look and read our first example. I will be doing both of these on Desmos as well. It says a population is initially 500 people. The population decreases by 32% per year. Determine when the population will be left with one person. All right, so in our example, we're going to have 10,000 people. It's going to decrease by 50% per year, and we want to know when there's just one person remaining. So let's go ahead and set up our equation. Remember, A is our starting amount. That's going to be 10,000. And we want to write 50% as a decimal. So we move that 2 to the left, and that would be 0.50. So 1 minus 0.50 to the power of x. So that is our exponential decay equation. And then we want to know when there's one person remaining. So our other equation will be the line y equals 1. Y equals whatever we want to see how long it takes that population to reduce to. All right, so let's go ahead and share our Desmos screen. And let's go ahead and do that. And there we go. Okay. All right, so Desmos should be popping up in just a second. All right, so should be able to see that now. So we're going to enter our first equation. Y equals 10,000 times 1 minus 0.50 to the power of x. And then our second equation, just y equals 1. Now you can see the y equals 1 line pop up there. The second equation starts way up at 10,000. So we're going to have to do some scrolling out to see that. And well, actually not too much. There it is already. And we can zoom in. And we're looking, remember where that's our first equation, our exponential decay. We can see the amount, the population decreasing at that exponential rate very quickly, and then eventually slowing down as time goes on. This line here is our y equals 1. We click on either of these to see our answer. Of course, the y coordinate is 1, but what we want to read is that x coordinate, because x represents the time in years, I believe. That would be in years, yes. And so they want us to, we're going to round to the nearest whole number, and we can see that that is 13.28. And so remember when we round, nearest 10th we're going to round to actually. And so that's either going to stay 13.2 or go up to 13.3. Well, how do we know? We look at the next number. Remember let's go ahead and stop sharing so we can see that here. So again, there's our answer in case you want to pause and take a look at that. And so 13.28, we only need to go to the second decimal place because we're going to round to the first one. The next number is at 8. Remember, our stay numbers are 0, 1, 2, 3, and 4. Our go up numbers are 5, 6, 7, 8, and 9. This is a go up number, so we're not going to stay at 13.2. We're going to go up to 13.3, and so our answer approximately 13.3 years. It will take, with our population, to go from 10,000 people down to just one person because we have 50% of the people leaving, moving out, whatever, per year. All right. So that is, you might have thought that would have taken a little bit longer, but no, only 13.3 years. And when you think about it, because every year you're losing half your population. So like after 1 year, it's gone from 10,000 down to 5,000, 5,000 down to 2,500 in just 2 years. So you can see that can decrease pretty quickly. And you see that quick decrease at the beginning, and then the amount of decrease slows as time goes on. But eventually it does get down to 1. All right, now our second problem here, second and final problem, it says a quantity of insulin used to regulate sugar in the bloodstream breaks down by about 5% each minute after the injection. A body weight adjusted dose is generally 15 units. How long does it take for the remaining insulin to be half of the original injection? All right, so in our example for number 2, we're going to have 40 units of insulin. It's going to decrease by 5% per hour. Make sure we got the right. Actually, we're doing minutes. I'm sorry. We're going to be doing minutes. Decreasing at 5% per minute. And we want to know when the amount of insulin is 1/4 of its original amount. 1/4 of 40 is 10. 40 divided by 4 is 10. All right, so let's go ahead and set up our equations for this one. Our starting amount is 40 units. And now our decrease amount is 5%, not 50%. So we're going to move that decimal over 2 to the left. And in that blank spot, we're going to put a 0. So while 50% is 0.5 or 0.50, 5% is 0.05. And so we want to be careful to make that distinction and make sure we get the right number in there. So that's our first equation. Our second equation, we want to see how long it takes to decrease to 10 units. So y equals 10 units will be our second equation. All right, we're going to share our screen and go into Desmos to do that. And so as soon as Desmos comes up, there should be just a second, and there it is. All right, so let's go ahead and enter those equations. We got y equals 40 times 1 minus 0.05. And of course, we could have simplified both of these. We could have done 1 minus 0.5, and that would be 0.5, or 1 minus 0.5, and that would be 0.95. You can do that, but no, you don't have to, and that just creates another chance for error, so we won't do that here. But often that is what's done. Our second equation is y equals 10. Now, again, remember we had scrolled the graph around. If you're not sure, if you don't see the graphs and you're not sure where you're at, just press this home key. That kind of resets you to the, now we still don't see them, but that resets you to the origin here where the x and y axis intersect. And now we can zoom out. We kind of know where we're at. And right away we see the exponential curve. We zoom out a little bit more to see the whole thing. There's the exponential decay. And there's our line y equals 10. We'll zoom in on that point there where the graphs intersect, because that'll be our solution. We click on either graph to get the gray dot. And of course, we're looking at the x coordinate because the x axis represents time in minutes. And we see 27.02. So 27.02, and we're going to round that. We see 27.02681, but we're just rounding to 1. And we'll stop sharing there, to 1 decimal place. So the options are to stay 27.0 or go up to 27.1. The next number is a 2. Remember our stay numbers 0, 1, 2, 3, 4, and this is a 2, so we are going to stay at 27.0. And so we have 27.0 minutes for our dose of insulin to decay or decrease from 40 units down to 10 units. Now, you might also say, worth mentioning here, you say, well, it's 27.0. Can't you just write to 27? And can't you just write 27? You could, but we are rounding to the nearest tenth. And by putting the 0.0 there, that's indicating that we did round to the nearest tenth. And it just so happens that the tenths, the number in the tenth spot rounded to 0. All right, so that's it for the examples for lesson 13.2. Just stepping out of the way in case you want to pause and look at that. So remember, pause, rewind the videos as needed. I'm sure you're going to do great with the work. And until next time, take care and God bless. Good luck with the work. And we'll see you in the next video. Take care and God bless. Bye-bye.